So let us take now question and answer on image compression. What is image compression? See, you have an image. In this image, say this data is filled, or you have pixels, or you can say it is in say frequency domain. So what happens here? That there is a lot of correlation or coherence. Means you will find the data such that you have value 22. So digital value you will find it 10 times or say 20 times. So this is the repetition first of all. And once you see the image, even if you take out certain data from here, the image will be same because our viewing capability is like this. Even if you remove certain some data from here, the eye will not perceive. So this is the basis of the compression, that the image can be made such that it is good to view, but it contains less data. Say an image is of say 10 MB, and if you are able to make it to say 500 KB, which is JPEG 2000 and all those various compression schemes that does. So now the transmission will be very easy from one place to another, and then also apart from transmission, storage will be good. So what is image compression? Image compression, it refers to the process of redundancy, that is a repetition amount of data required to represent the given information or quantity of information in the digital image. So the basis of reduction process is removal of this redundant data. The basis of reduction process is removal of redundant data. What is data compression? What do we mean by data compression? Data compression requires the identification and extraction of source redundancy. In other words, data compression seeks to reduce the number of bits which is used to store or transmit the information. So we are interested in storing and transmitting, but for that, if we can reduce the number of bits, then we say that we have done the data compression. What are two main types of data compression? There are two types of data compression: lossless and lossy compression. In this lossless compression, we can recover the exact original data after the compression. So it is used mainly for compressing database records, spreadsheets, or word processing files where exact replication of the original is required or essential. While in lossy compression, this will result in a certain loss of accuracy in exchange for substantial increase in the amount of compression. So lossy compression is more effective when used to compress graphic images and digitize voice, where losses outside visual or oral perception can be tolerated. So if visually or orally we are not able to, or audio visually we are not able to perceive changes, then we can have lossy compression, and it doesn't degrade the quality also. What is the need for compression? Why would we require compression? First of all, in terms of storage, the capacity of a storage device can be effectively increased with the methods that compress a body of data on its way to storage device and decompress it when it is retrieved. So if you have a storage element to store in the storage area, if it can be stored and then when it is retrieved, it can be again decompressed. So this is also a need for compression, but there are various others, like in terms of communication. The bandwidth of a digital communication link can be effectively increased by compressing the data at the sending end, means transmitter TX, and decompressing data at the receiving end, RX. At any given time, the ability of the internet to transfer data is fixed. So if data can be effectively compressed, wherever possible, significant improvements of data throughput can be achieved. And many files can be combined into one compressed document, making sending quite easier. What are different compression methods? There are various methods. Few of them are: first is RLE, run length encoding, then arithmetic coding, Huffman coding, and transform coding. Define the coding redundancy. What is coding redundancy? If the gray level of an image is coded in a way that uses more code words than the necessary to represent each gray level, then the resulting image is said to contain the coding redundancy. What we are trying to say here is, if the gray level or DN values in images are coded in such a way that it uses more code words than necessary, when these redundant code words are used, then we call it as a coding redundancy. Define the interpixel redundancy. What is interpixel redundancy? Inter means the redundancy between the pixels. So interpixel redundancy we are talking about. The value of any given pixel, that can be predicted from the value of its neighbor. Of its neighbor. So the information carried by is small. So therefore the visual combination of single pixel to an image is redundant. Otherwise, this is called as spatial redundant, geometric redundant, or interpixel redundancy. For example, run length RLE is a kind of interpixel redundancy. What is run length encoding? In what we do here is, if we have number of say 0 and number of say 1 or 5, so we can write like this: 4 0 and 5 1. Okay, 5 ones and 4 0. So this is I'm just giving you an example that how 1 2 3 4 5 6 7 8 9 characters can be compressed to 4. And run length coding in this technique, this is used to reduce the size of a repeating string of characters, like as you see here. So this repeating string is called a run. This is run. So RLE encodes a run of symbols into 2 bytes. First is your count. This is the count, and then the symbol. This is count and this is the symbol. So RLE can compress any type of data regardless of its information content. But the content of data to be compressed, it affects the compression ratio. Compression is normally measured with the compression ratio. We'll see the compression ratio. Define compression ratio. Compression ratio is nothing but the original size divided by the compressed size. So this is compression ratio. Define the psycho-visual redundancy. What is psycho-visual redundancy? In a normal visual processing, certain information has say less information or less importance than other information. So this information is said to be psycho-visual redundant, which is having less importance. Define the encoder. What is an encoder? Source encoder. These are source encoder, and you have source encoder and channel encoder. So source encoder is responsible for removing the coding and interpixel redundancy and psycho-visual redundancy. So it has two components: source encoder and channel encoder. So what is source encoder? Source encoder performs 3 operations. First is it does mapping, quantizing, and then symbol encoding. So in mapper, this transforms the input data into non-visual format. This transforms the input data into non-visual format, and it reduces the interpixel redundancy. What quantizer does is it reduces the psycho-visual redundancy of the input images, and this step is omitted if the system is error-free. Then we have system encoder. This reduces the coding redundancy, and this is the final stage of encoding process. Define channel encoder. The channel encoder reduces the impact of the channel noise by inserting the redundant bits into the source encoded data. For example, humming code. This humming code is an example. What are the types of decoder? As we see that this decoder or source decoder has 2 components. First is symbol decoder and inverse mapping. Symbol decoder does what? This performs inverse operation of symbol encoder, and inverse mapping this performs inverse operation of mapper. And channel decoder, this is omitted if the system is error free. What are the operations performed by error free compression? First is to devising an alternative representation of the image in which its interpixel redundancy are reduced, and then coding the representation to eliminate the coding redundancy. What is VLC or variable length encoding? Variable length encoding is the simplest approach for error-free compression. It reduces only the coding redundancy. It assigns the shortest possible code word to the most probable gray levels. What is Huffman coding, and mention its limitation? Huffman coding is again a method or popular technique for removing the coding redundancy. So when coding the symbol for an information source, the Huffman code yields or produces the smallest possible number of code symbols per source symbol. So smallest possible number of code words or code symbol per symbol source. The limitation of this is for equiprobable symbols, Huffman coding produces variable code words. What is block code? Each source symbol is mapped into fixed sequence of code symbols or code words. So it is called as block code. Define the instantaneous code. A code word that is not a prefix of any other code word, is called instantaneous or prefix code word. Define uniquely decodable code. A code word that is not a combination of any other code word is said to be uniquely decodable code. What is B2 code? B2. Each code word is made up of a continuation bit and information bit, which are binary numbers. So this is called B2 code or B code. So this is called B2 code because two information bits are used for the continuation bits. Define the procedure for Huffman shift coding. Define the procedure for Huffman shift coding. We list all the source symbol along with its probability in the descending order. We divide the total number of symbols into block of equal size first. Then we sum the probabilities of all the source symbols outside the reference block. And then we apply the procedure for reference block, including the prefix source symbol. And the code words for the remaining symbols can be constructed by means of one or more prefix code followed by the reference block, as in the case of binary shift code. Define the arithmetic coding. In arithmetic coding, one-to-one correspondence between source symbols and code word doesn't exist, whereas the single arithmetic code word assigned for a sequence of source symbols is there. So a code word defines an interval between number 0 and 1. This is arithmetic coding. So this was about compression. Thank you so much. Take care.